Hi guys, welcome to day 2 of learning stuff. This is section 1.2 we're covering today, which is about graphs of equations. So there are 4 things we should learn how to do by the end of today. Number 1, sketch a graph by plotting points. Number 2, find intercepts of a graph. And these 2 topics are going to be the topic of this first video we're shooting right now. And then the third topic is to find symmetries in a graph. There's 3 types of symmetries that we'll look at. And then lastly, how to find the equation of a circle, and then also how to see important points within that equation if you wanted to graph it. Okay, so we're starting with, oh, sorry, there's a typo here. I'll fix the notes to say day 2 before I upload it to our page, our Llamaku page. Okay, so the first topic is to sketch a graph by plotting points. And to me, this is probably the most straightforward of all the topics today. And all you do is just make a table of x and y coordinates, and then you just plot them. A couple of tips though, try to pick nice points. When I say nice points, I mean points that are going to make your calculations easy. A lot of times that means picking x as 0 or y as 0, or x is 1 or y is 1. Other times you got to look where the equation you're looking at is defined. That's also typically a lot of times where you're going to get some nice values. So like you'll see in the very first example, an instance of that where you have a square root, and if the square root is negative, it's not defined. So you want to look right where the square root would be at 0. Okay, so that's the first topic, sketching graph by plotting points. 2 tips, pick nice points and pick points that are like important looking at your equation. Then the second topic is to find the intercepts of a graph. And when you're finding intercepts of a graph, if you want the y-intercept, you plug in x as 0. And then if you want the x-intercept, you plug in y for 0. So just a tip, note that the letters are opposite. And why is that? Let's just look at a quick picture here. So look at this picture, right? This is a Cartesian coordinate system. X-axis is right there. Y-axis is right there. If I'm looking for the y-intercept right here, note that that's right when x is at 0, right? The left and right values are 0 to make you intercept the y-axis. And it's the same the other way around. Like if I'm looking for the x-intercept instead, sorry, just changed colors for no particular reason, but this is x, this is y. If I want to know a point that crosses the x-axis, at that position, y is 0, right? Because here's y, 1, 2, here's -1, here's -2. Y is right there at 0 when you cross the x-axis, right? Whatever your graph is. Okay, so those are the first 2 topics. We're going to jump straight into the problems now as examples. What I recommend is you can maybe watch the first one as an example and then try the rest after that. And then you can check your work. I'll also show you how I expect you to show your work. So problems are at the bottom of the second page. Now, since these are graphing questions, I actually copied and pasted these to my own graphing paper. You don't have to use graphing paper. You can just use, your regular paper. Just try to sketch it as best you can and make it as straight as you can. It's nice if you use a ruler, but I'm not requiring you to. Just a rough sketch. Okay, so we're trying to plot this thing using x and y values, right? And so this is what I was saying earlier. Oh, sorry, I forgot to turn my notifications off. So this is what I was saying earlier. Try to pick points that are easy or nice. So looking at this thing right here, the thing that makes this part 0 is if x is equal to 4, because 4 squared is 16, right? And then you get 16 minus 16 is equal to 0. So here's the kind of minimum work I'd expect you to show. So x I'll plug in as 4. That would make this 16 minus 4 squared is 16, which makes the overall thing 0, and square root of 0 is 0. So I expect you to show at least this much. Now, it might be nice to also show your calculation somewhere. So you can do that all in the same line if you want. So I'm going to do that for -4. If I plug in -4 for x, this is going to be the square root of 16 minus -4 squared, right? And I'm just plugging in this right-hand side of that equation there. So that's going to give me square root of 16 minus negative 4 squared is 16. 16 minus 16 is 0. So I've got the square root of 0, which is just 0. So that's the work, right? That's how I would have gotten that 0. But, you know, that calculation part, you don't have to show that in a question like this, because the point of this question is really just to figure out the graph, yeah, based on which points you pick. Okay, so those are two easy points, nice points. The other obvious choice for a good point would be when x is 0, right? If I plug in 0 for x, that's going to give me the square root of 16, square root of 16 minus x squared, and x here is 0, so 0 squared, which is the square root of 16, and the square root of 16 is 4. Okay, so I know that it's 4. Now I'm going to leave the work this time. So that's actually nice work that I would appreciate if I'm grading an exam or something. But the minimum I require for a question like this would be at least show me the table. Okay, and then so with those points, let's plot them. And the first point is 4, 0. So let me think, actually. I should actually make this exactly on the lines, yeah. That would be the most obvious thing to do. There you go. So 4, 0, here's 1. Let's do half marks. So this would be 1, 2, 3, 4. 4, 0 would be right there. And then we'll do negative 4, 0. 1, 2, 3, 4. That's the second point. And then I've got 0, 4. So 0, 4 would be 1, 2, 3, 4 up here. Right there. Okay, sweet. So those are the important points. Beyond that, it wouldn't be defined, right? Because then you have a square root of a negative. Beyond that, and this way also same thing. So this is actually the whole domain of the function. And I'm going to just sketch the graph by connecting those points. No, I don't want to line. Okay, I'm not very good at making a nice, this is a semicircle, but, missed it. But you get the idea, right? This should be a semicircle. And this is something we'll see later. That's really crooked, but just imagine straight. Sorry, it's kind of hard to draw on this iPad here. But it's a semicircle, and we'll actually see later in this lesson is that is a typical equation for a semicircle. Okay, first graph done. On to the second one. Second one is actually very similar. This time you got x's and y's switched though. So here's something interesting. You know, when you make your x, y table, you don't always have to start with filling the x value in first. You can actually fill the y value in first if you want to. And here, looking at this thing, the number that's going to make things look nice would be a negative 7, right? If I plug in negative 7, this is going to be y squared. That's going to be 49. So I have 49 minus 49, which is 0. Square root of 0 is going to be 0. Negative of 0 is still going to be 0. So I'm going to get a 0 there. And same thing if I plug in a positive 7. I'll also get a 0 by the same reasoning, right? Now, another nice point to check would be when y is 0. If y is 0, you're going to get, and here's where we could do the work right here. This is going to be negative the square root of 49 minus 0 squared, which is negative square root of 49, which is negative 7. Okay, so this gives me negative 7. So that's what I'm going to put right there. I have my 3 points, and my graph is going to look very similar to what it looked like in the previous question. So I've got this time 0, negative 7. So let's see, 1, 2, 3, 4, 5, 6, 7. Yeah, okay. So 1, 2, 3, 4, 5, 6, 7. 0, negative 7. Oh. That's right. Yeah, that's right. And then 0, positive 7. So 1, 2, 3, 4, 5, 6, 7 right there. And then I've got negative 7, 0. So that's going to be 1, 2, 3, 4. Oops, missed the line. 4, 5, 6. Not like I'm totally accurate every, but you know, get negative 7. So negative 7, 0 right there. So again, I have a semicircle. This time, because it's x equals some square root of something minus y squared, it's going to be a vertical semicircle this time. And this negative makes it on the left side as opposed to it normally would be on the right side. Okay, so again, we'll try to draw a semicircle. Oh, so good at the end. But, you know, that's it's supposed to be a semicircle. Yeah, hopefully you can draw better than me. Maybe use a compass or something. There's probably a circle drawing tool here somewhere. I haven't figured it out yet, so sorry about that. Okay, guys, 3 more to graph. So this one, same idea. Here's my XY table. Let's try it 2 different ways this time. So I'm going to plug in a value for x first, 0. And then we'll see if x is 0, what is y cubed equal to, right? So x is 0. The other side is y cubed equals to 0. So then you'd say, okay, then y must be 0. You could solve it for that way. Actually, you know, that's not so intuitive. I think the more intuitive way is to plug in the 0 for y, right? Because why do I do that? Because x is already isolated. So it makes more sense to plug in the numbers for y, and then you can just work out the function that way. Does that make sense? Because x here is equal to y cubed. So x is a function of y in this case. So x equals to y cubed. If y is 0, that's 0 cubed, which is 0. Okay, another obvious choice would be -1 and +1. If y is -1 here, that's going to be -1 to the 3rd power, also -1. If y is +1, y to the 3rd power is going to be +1. Right there. I'm going to do 2 more to get a better feel for this one. What about -2? If y is -2, -2 cubed is going to be -248. And if y is +2, it's going to be +248. Okay, so that gives me a good idea where my function is going, what it looks like. I already know, you know, just certain graphs you kind of just get used to. And this is one of those standard polynomial types, like this, you know, a y cubed graph. You might be more familiar with it as y equals to x cubed. And then we know that one looks something like this, right? But then if it's the other way around, it should have a similar shape. It's just going to be it should be kind of turned on its side instead. But let's check, okay? So 0, 0, that's the first point. -1, comma, -1. We're going to do by half steps as values. So -1, -1 will be right there. +1, +1, so that'll be right here. Okay, next one is -8, -2. So that's -8 would be -1, 2, 3, 4, 5, 6, 7, 8 over here, and then -2, -1, 2. Okay, I think yeah, sketch I made earlier was actually backwards if I think about it. Okay, then 8, 2, 1, 2, 3, 4, 5, 6, 7, 8. 8, comma, 1, 2, right there. Okay, so now connect the dots. Okay, wish me luck, guys. Something like that. Okay, it looks like a 2nd grader drew that, but you get the idea. Okay, so if you look at it though, it's like very similar shape, right? Except it's just kind of it's like it's actually what it really is it's rotated along this line. Oh, I missed. It's rotated along this line of y equals to x. Right? If I look at the graph of y equals x cubed, it should look something like this. So it's actually the reflection over that y equals x line, because what you're doing is you're switching x and y, right, compared to y equals x cubed. Sorry, that's a side note, guys. We're not talking about that too much right now at the moment. We're just talking about graphing the things. So let's move on. Okay, now we got some absolute values to graph. Absolute values. This is standard absolute value, except it's, again, switching the x and y, right? So, you know, absolute value is another type of graph that you should be very familiar with. It just looks like a V. That's the standard absolute value graph, like if it was y equals to x cubed. I'm sorry, not x cubed. Y equals to the squared. Hold on, let me slow down. Y equals to the absolute value of x. Should look like a V. So I'm expecting a V shape too, maybe something like this or something. But let's find out. So let's say x is going to be This time, again, x is a function of y, right? X is by itself. So if x is by itself, I'm going to plug in values for y. So let's try y equals 0. Let's try -1, +1, -2, +2. This is kind of like our typical easy points to check. Okay, if y is 0, absolute value of 0 is still 0. Y is -1, absolute value is going to be +1. 1 becomes 1, -2 becomes 2, and 2 stays as 2. Right? It's just a positive value of whatever we started with. So now let's go on to graph. Okay, and from now on, we're going to kind of stick as much as possible to that same scale. These will be 1. Each half block will be 1. So 0, 0 is right there. 1, -1 would be 1, -1 right there. 1, +1 would be 1 right there, like that. 2, -2 would be 1, 2, -1, 2 right there. And 2, +2, 1, 2, 1, 2 right there. Okay, so like we expected, right? This thing, it does look like a V, but instead of opening up and down, it opens sideways. Here's your x-axis, here's your y-axis. Sweet. Okay, moving on. Okay, here's an interesting one. You know, I don't remember ever seeing this one, honestly. Absolute value equals to the absolute value of y. But we'll find out what it looks like. Okay, my prediction is a line. I'm not really sure. Okay, so let's see what happens. If x is 0, then the absolute value of x is going to be 0, right? And what value of y is going to give you the same value? Well, it's got to be 0. Okay, what if x is -1? If x is -1, then this side equals +1, right? And what about y? Well, y could be also -1, because then the absolute value is equal to +1. Or y could be +1, because then the absolute value is still equal to +1. So actually, you've got a couple options here, right? Y could be, if x is -1, y could be, y could be -1 or +1. Now, I could also think about it the other way, right? If y is -1, then x could be -1, or it could be also +1. So I get a few different options here. So let's see what this graph would look like then. And this one is not considered a function because you get more than one value. Well, even some of these other ones weren't functions. Like this one wasn't a function because it doesn't pass the vertical line test, right? You get more than one value for one single x value. This one even more so. Well, let's start. First of all, 0, 0 is easy. But here's some ones that work, right? If x is -1, y could also be -1. That's the point. But if x is -1, y could also be +1. Oops. So that's another point. Okay, but if x is +1, well, y could be -1, or y could also be +1. Right? And this kind of idea would work for other values too. Like let's say x was -2. Well, y could be -2 as well, or +2. And similarly, if x was 2, well, y could be -2 or +2, either way. Right? So we have all these different combinations. So 1, 2, 1, 2, they could both be +2, or they could both be -2 over here. Or x could be positive, y could be negative, x could be negative, y could be positive. So your graph kind of looks like this, where you've got this V going out upside down and in both sides, right? So you got this X going on. Here's x-axis, here's the y-axis. All right, one more, and then we're done with this first topic, first video. Okay, absolute value x plus absolute value y equals to 1. Oh, interesting, interesting. Okay. So, yeah, you know, to be honest with you guys, these are kind of tricky. Like, as far as questions where you're just plugging in points, these are a little on the tricky side. So, yeah, I think generally speaking, like a question that I would typically give you, probably not one with these two absolute values like this on an exam. Okay, but let's just figure this thing out. Okay, so what if x is 0? If x is 0, then that leaves me with, let's do some figuring out here. 0 plus absolute value of y is equal to 1. Okay, which means, that implies the absolute value of y is equal to 1. So then y could be equal to two things, -1 or +1. See that? Okay, if you missed it and you didn't want me to delete that, then you just rewind 10 seconds. The video. That's the nice thing about videos. Okay, now what if x is, let's do -1 first. If x is -1, then I've got absolute value of -1 plus absolute value of y is equal to 1. That implies 1 plus absolute value of y is equal to 1. And then to solve this, you subtract 1 from both sides, right? And then what that leaves you with just the absolute value of y on the left side. On the right side, you get 0. Well, the only way absolute value of y equals to 0 is if y itself is equal to 0. So you get that point. Y is equal to 0. Oops. There you go. Come on. Okay. Y is equal to 0. And okay, what happens if x is 1? Well, the same exact thing's going to happen, right? This absolute value of x is going to be 1. These ones are going to cancel to give you 0. And so you get y, again, equal to 0. Okay, interestingly, you note that this this equation, if I just switch the x's and y's, it's the same thing, right? Either way, like it's if I say absolute value of y plus absolute value of x equal to 1, I get the same equation. So that means really I get the same result. If I was to plug in -1 for y instead, this would be x, absolute value of x plus 1 is equal to 1. Let me just show you what I mean. So let's say I put in -1 for y. Well, then I get on this side, absolute value of x plus 1 is equal to 1. So absolute value of x is equal to 0, which means x is equal to 0. Okay, so I get some more points for free. -1 and 0 and +1 and 0, like that. Okay, so let's plot what we have so far and see what it's starting to look like. All right, so first of all, I have 0, -1, or 0, +1. Oh, by the way, guys, I just realized. No. Okay, never mind. Sorry. I was gonna say I kind of have the same thing, right? If I have 0, -1 on the other direction. So 0, +1, 0, -1, or I have -1, comma 0, or +1, comma 0. Oh, I'm sorry, guys. I just realized. Yeah, this last part was redundant because I already did it in the top already. So let's just take that out because I did those already. Okay, so I got those points. Let's see what else. Let's see what else I have. So let's do 2's. Let's say x is -2 first. Then I have absolute value of x is going to be +2 plus absolute value of y is equal to 1. So that means that absolute value of y is equal to, oh, this is interesting. Okay, this is, to solve this is going to be -1, right? But this can't happen. That cannot happen because the absolute value of something can never be negative. So that means -2 is outside of my domain, which is good news for me because it means that, let's see, there's no solution. Right? It means that I can't go past here in my equation. In fact, I probably can't go past this -1 actually. That's going to be my, where I have my limit. Okay, so that means same thing is going to happen if I go for any of the other ones, right? If I go for +2 here, same thing. If I go for +2 or -2 for y, it's going to be the same thing. That means my whole graph has to be contained in this little region right here, this little area. Okay, so then what I'm thinking is probably going to happen then is I'll have something probably like this. But let's check one more point. Let's do a half, okay? So let's do a half. So if x is a half, absolute value of x plus absolute value of y must equal to 1. So y could be a half as well, or it could be a negative half. And similarly, if I do half on this side, it could be negative a half or positive half. So that's interesting. 1/2 would be halfway here, right? That's this. Or halfway this. Or halfway here. Or halfway here. Oops. Missed. So now, same thing, the same kind of pattern is going to continue connecting these dots. You have what I was suspecting earlier, right? You get this little diamond here. So that is your graph for that thing. Sorry, this diamond is supposed to look more like a perfect diamond, but that's the idea. All right, guys, that's it. I'll see you in the next video.